Alright, we're going to take a look here at ratios, both 2-term and 3-term ratios. So as we go through this, today's a lot of definitions, which is why I put this on a video here. So take a peek as I'm basically just making sure you can understand here. So a couple definitions. Important when we're dealing with these, we're talking about when we have a ratio, it's something with the same units. So if we're comparing two quantities with the same units, it's a 2-term ratio. Alright, surprise, surprise, if we're comparing 3 quantities with the same units, here we're looking at a 3-term ratio. Use some ditto marks and away we go. Alright, so we want to look at some examples here. What's the ratio of the zebra stripy tiles to the white tiles? So this is going to be a 2-term ratio. Now we can either look at this thing on the side here that I circled, or broken it down into nicer, easier to count. So our ratio of stripies to white tiles. Let's take a peek here. What we should see is that there are 3 stripy tiles, and there are 6 white tiles. So we can write this as a 2-term ratio. In ratio notation, 3, and then we put a colon. Now we'd read this as 3 to 6, but it's a colon that we're writing there. Eventually we're going to get to writing this in lowest terms. We do need to be a little bit careful with the lowest terms bit, simply because we have to write down what the factors we're using. We could also write this as a part-to-part ratio. So we're comparing 2 parts of the group. We could write this in words, 3 to 6. We can't write this as a fraction, not unless it is a part-to-whole ratio, which we'll get to those in a minute. So writing in lowest terms, we can divide both of those 3 and the 6. We can divide them both by 3. Show that in a couple different ways, but generally what you're going to see here is exactly the best way to do that. We can divide both the 3 and the 6 by 3. Just going to record that we are dividing by 3. Okay, so we're dividing both of them by the greatest common factor. Audio got interrupted there. 3 divided by 3 is 1, 6 divided by 3 is 2, so this becomes a 1 to 2 ratio. Alright. We can also look at a 3-term ratio here of the white to the zebra stripy to the black ones. Okay. What we should be able to see is there's 1, 2, 3, 4, 5, 6 of the white ones. We've got 3 of the stripy ones and 3 of the black ones. So we could say this is a 6 to 3 to 3 ratio. Alright. Ratios in numbers 1 to 3 there are called part-to-part ratios. This is definitely not the neatest writing you've ever seen. Even for me, it's quite terrible. But life goes on. Part-to-part ratios. Because they compare different parts of the whole group. Right? Part-to-part ratios are written in ratio notation. as I leave the line, this just goes absolutely crazy here. Or we can also write them in words. Or if you want to be really correct, word notation. All right. So as we continue here, what is the ratio of white tiles to the total number of tiles? Well, we can count them up. There's a grand total of 6 white ones. And 6, 7, 8, 9, 10, 11, 12 total. Or we can look at the rectangle, and there was 3 by 4, so area there is going to be 12 tiles. So 6 white tiles to 12 in total. Okay, and then again in lowest terms, we should be able to see, hey, I can divide both of these by 6. I apologize if you hear any crunching noises. My dog has decided now is a good time to eat her meal. Crazy dog. 6 divided by 6 is 1, and 12 divided by 6 is 2. Again, we could also write this as a fraction because this is now a part to whole ratio, which we're going to talk about in just a moment. And divide top and bottom of our fraction both by 6. And we get the same result. This is a 1 to 2 ratio, or 1 out of 2 in that entirety of squares. 1 out of 2 of them are going to be the white ones. 1 out of every 2, if you like. All right. So we've got a whole big old typo going on here, and I'm going to take a moment and try to correct it. What this really should say is this ratio in number 4 is a, it takes me a while to get there, but the ratio in number 4 is a typos going all over the place. And this is going to be a part to whole ratio because it is comparing one part of the group to the whole group. All right. Part to whole ratios. Apparently I did not give us enough room on this line, but that's okay. Okay. 5 different ways we can write these guys, and if you look down below in your notes, you can see all 5 of them. We can write them in ratio notation, which is what when you first started learning about ratios, you dealt with this. I'm not going to write the word notation. We can write them in words, or word notation. Okay. We can write them as fractions, which we already looked at, and I know you did back in grade 6. I think was about the first time you start seeing them as fractions. We can also look at them as change our fractions into decimals. Or we can look at them as change that decimal into a percent. Right. So coming back to what we just looked at there, course, we can look at this ratio of white tiles to total tiles. As a fraction is going to be how many of the part divided by the total, or part over the total. So the number in the part is our numerator, our total is the denominator. We could write it as a decimal notation. Right, so if we're using our calculator, it's just going to be top divided by bottom for decimal notation. We can also simplify a fraction like this, and sometimes that makes decimal notation easier to figure out without even a calculator. Right, 1/2, this is one that you should know is 0.5. We could also change that to a percent, right? We multiply our decimal by 100, and that's going to give us a percent. Also should know that half is 50%, so either of those ways work. Right. Not my best 5 in the world. Now, one place where you might see this decimal notation in sort of real life is if you're looking at baseball stats. So we hear that a batter is hitting 300. What that means is roughly 3 out of every 10 at-bats, they're going to get a hit. And by the way, that is a good batting average if you're a professional baseball player. All right. Scooting down here, just some quick questions here, right? You spend $30 out of 100. What type of ratio is this? Well, we should know that this is the total is 100, so it's a part to whole ratio. I'm just going to abbreviate with a P and a W there. Okay. Now, in ratio notation, we can pop this down here, and we're going to have 30, and then we'll put a colon. 100. Again, we'd read that as 30 to 100. All right, we can simplify that, right? They're both divisible by 10. And we'll end up with a 3 to 10 ratio. In this case here, that might not be the most useful, right? Because we're actually saying that you spent 30 full dollars, which is, although it's true you spent 3 out of every 10, if you don't know that the total was 100, it seems like it's more work than it's worth there. Word notation, we could write out the word 30 if we wanted, THIRTY, or we can just write the digits. So we have a 30 to 100 ratio there. As a fraction, same thing here. We can write this 30 as our numerator, the part, and 100 on the bottom as our denominator. Again, we can simplify this if we need to. Question asks us to. Divide top and bottom both by 10. We get 3 out of 10. As a decimal, again, if we're not sure, we should be able to see that this is 0.300 or 0.3. We could also say, okay, top divided by bottom, pop it into our calculator, and away we go. Percent notation. We can take that 30 out of 100, remembering that percent means out of 100, and that's 30%. Or we take our decimal and multiply by 100. Either way is going to get us there. All right. In terms of the questions at the end, they're all pretty straightforward. Those last two are a little bit more of a challenge. Have fun with those, and good luck. Thank you. Also, as you get at these here, take a look through numbers 10 to 15. If you still need more to do, pick one of those. Whichever looks easiest to you, give one of those a try as well. Thanks.